Donna, 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 dun, dun. All right, what we're doing is we are measuring 120 students' backpacks. We find an average weight of 30.5. Online it said 25 really is where your backpack ought to max out. Now, the way we set up our hypothesis test is going to change the way we do it. Let's try this. Let's ask the question, are the backpacks 25 pounds or more? That has equals 25 pounds and greater than 25 pounds together. Because equal sign is here, that's my null hypothesis. The alternative would be less than, set my alpha, there's my z-score. Based on this, I can draw my picture, which looks like this. Now I want you to notice, this less than here means it is left-tailed in area. There is where my alpha equals 0.05 lands. That is my rejection region. If x bar lands in the red, I will reject my null. It did not land anywhere near the red. It is clear over there, which means my p-value is really big, 0.99870. And so our p-value is going to be from here all the way to the left because it's left-tailed, and that means fail to reject. We cannot show that the claim of 25 or more is wrong. Now, let's change our question right here. Let's make it now say, can we show the backpacks are more than 25 pounds? More than is greater than. Greater than, but I'm not saying there's an equals here. So, mu greater than 25, that has to be in our alternative. That means the null is going to be a less than or equal to 25. Greater than means my alpha region is now on the greater than side. There's where my 0.05 is. So the p-value is going to be from here, that little tiny area there, which is 0.0013, super small. Now we will reject the null because our 30.5 is way out in that red region. And so we can prove that the average is greater than 25 pounds. Oh, I am a statistician. How do they do that voice? So let me recap. Thank you. Every time we change the question, it's changing which direction our question faces. Some things don't change. Same z-score, same alpha, but the null and alternative will change and so will the p-value. Now it says, can we say that the backpacks are 25 pounds on average? That's an equals. Does it equals 25 pounds? So that's the null, equals 25. The alternative would be does not equal 25. Not equals means it could be too low or too high. So that rejection region, it's not going to be left or right, it's going to be both. That's called two-tailed. So our alpha is now 2.5% here and 2.5% there. The full alpha is still 5%. And if our line lands in this red region, we'll still reject, same rule. But when we look this up on the table, we get an area of 0.013. And we could compare the 0.0013 against the 0.025 to tell whether we're in that rejection region. But we won't want to use that because this is a half alpha. We want to compare it to a full alpha. So if you're going to take this little area, compare it to the full alpha, you need to also double the area on there, 0.0013. So your p-value now becomes doubled because you want both sides. Instead of 0.0013, it's going to be 0.0026. That's the number that you can compare to the alpha. In other words, when you're dealing with a two-tailed example, your p-value is how far away you could be from the null in either direction. The fact that you landed here is only half the story. You could have also landed over here, and the two-tailed test wants both those probabilities. So what you're going to do is you're going to look up the area on the table, find that tail piece, and then double it to pick up the other area. That's your full p-value for a two-tailed test. That's what you compare to alpha, and your conclusion is going to be reject, and the average weight is not 25. It's not fair to say we've proven the average weight is more than 25 because we didn't test for more. We just tested for different. Yes, it's different. It happens to be different on this end, but it could have been different on some other end. So our conclusion says it is not 25 pounds.